Today we discuss that is a multiple and partial correlations topic. In this I am Dr. Animoni Nagaraju, professor. Here our total concepts we discuss, we will totally focus on partial correlation and regressions and multiple correlations. Whenever that it is one dependent variable, it is involving to the one or more independent variable, but any one independent variable it will be effect. That criteria we will discuss in this unit. In this particularly here multiple and partial correlations. Multiple and partial correlations, here first objective is a multiple and partial correlations, what we will, how it will be exist and how, what we can understand, how we will be solve. Next, express the multiple and partial correlation coefficients in the terms of simple correlation coefficients, and to study the properties of the multiple and partial correlation coefficients. These three are the major important objectives of this unit, in this concepts. Now, we go for that is introduction. In the previous unit, what we studied about that is a regression involving the one dependent variable and the two independent variables. That concepts is already a regression equation we identified, and studied that is a relation between the two variables, how it will be dealing with the trivariate data, that concepts completed. Now, in this such situations can adopt that is one of the following approaches. That is our today concept lecture. We may only consider that is a values of the two variables of interest by keeping the value of the third variable at a constant level. So, here I am going to putting the condition is a third variable at constant level. This approach has to be the disadvantages of the limiting the size of the data. Next, coming to the, we may eliminate the data, eliminate the effect of the third variable. What it is affecting, that we will go for that is eliminate on the two variables of the interest, and then study the relation between them. It may not be possible to remove that is the entire effect of the third variable on the variable of interest. However, it is removed, that is a linear effect. That linear effect, anything will be there, that we can be removed. This is a overall idea about it. Here two things, approaches I am following. One is your values, third variable values it at the constant level, we will be fix it, and it is also one of the disadvantages of the limiting of the size of the data in this approach. Even though we have to be try, then again is the eliminate, that is the effect, whatever the effect is there, that effect, it is also not possible. But even though we will try to effect of the third variable, it is a wherever it is removed, that is a linear effects will be there, that we can be removed. That criteria we will be apply for this concept. Partial correlation and regression. In this correlation and regression, two variables after the elimination of the linear effect of the other variables on them are called as a partial correlation and regression. This is a oral idea about that is what is the definition means. It's the correlation and regression between the two variables are after the elimination of the linear effect of other variables on them are called as a partial correlation and regression. Next, partial correlation coefficient, how it will deal. So, it is a suppose it is a dealing of the data is a trivariate data, the correlation coefficient between that is a two variables after the linear effect of the third variable on each of them is eliminated, is called as a partial correlation coefficient. So, partial correlation coefficients are denoted as a R 12.3, R 13.3 and R 23.3, like here the R 13.2 and R 23.1, like that. It is a we can take that, it is a coefficient, partial correlation coefficients. Next, it is a residues. If I come to that, it is a x 1.3, it is equal to the x1 minus b13 b13 and b13 x3 may be the considered to the part of the variable x1, that remains, that is after the linear effect of the variable x3 is removed. Here in this linear variable is removed. In this similar manner, it is a x23 equal to x2 minus b23 x3. So, here also x2 remains after the linear effect of x3 is eliminated. The partial correlation coefficients are 12.3 is the correlation coefficient between the x1 3 and the x23 is given by, it is we have some formulas, correlation coefficients we can be identified from the formula. Correlation coefficient between the R 1.13 is and x23, that it is a R 12.3 equal to R 12 minus R 13 R 23. divided by root of 1 minus R13 square into 1 minus R23 square. R13.2 equal to R13 minus R12 R32 divided by root over 1 minus R12 whole square into 1 minus R32 whole square. R23.1, if I take that, is equal to R23 minus R2 R21 R31 divided by root over 1 minus R21 whole square into 1 minus R31 whole square. Now, example, I am going to explain that is one example. In the trivariate data, R12 equal to 0.6, R13 equal to 0.4, R23 equal to 0.5. He has given that is some coefficient, what is the correlation coefficients. Next, to find the value of the partial correlation coefficients, he will ask in the examination. So, partial correlation coefficients we can identify R13.3, R13.2, R23.1 by using the above partial correlation coefficient formulas. So, R12.3 equal to, I will write the formula R12 minus R13 R23 divided by root over 1 minus R13 whole square into 1 minus R23 whole square. So, it is, I will get the obtain, that is the value after substitution is 0.3175. R13.2, if I take R13 minus R12 into R32 divided by root over 1 minus R12 whole square into 1 minus R32 whole square, that value is 0.1443. R23.1 equal to R23 minus R21 into R31 divided by root over 1 minus R21 whole square into 1 minus R31 whole square. So, 0.3546. Like here we can obtain, that is what we needed, that it is the partial correlation coefficients. Whenever he will use, that is a correlation coefficients. Next, partial correlation coefficients helps in the deciding the whether that is additional independent variable should be included in the regression analysis or not. That it is a it will be help that whether we should be include or exclude that, like that. That such situations it will be helpful for the partial correlation coefficient. Next is if R12.3 and then R12, how do we identify R12 equal to R13 into R23? It implies that R12 will not be the equal to the 0 if X3 is correlated with the both X1 and X2. Now, the previous unit obtained the equations of the plane regression equations, so that B12.3 equal to what are the formulas we have? Minus sigma 1 omega 12 by sigma 2 omega 11, and B21.3 equal to here minus sigma 2 omega 21 divided by sigma 1 into omega 22, and R12.3 whole square equal to B12.3 into B21.3. That implies R12.3 whole square equal to omega 12 whole square divided by R omega 11 into R omega 22. So, R12.3 equal to minus omega 12 divided by root over omega 11 1 omega 22. So, it is here we take that is a negative sign, because of it is a regression coefficient have the negative sign. This is only the equation of the plane regression, so how we can be obtained. Now, I am going for that, it is a multiple correlation. Here, if we are interested in the studying the joint effect of grouping of the variables on another variables that was not included in the group. So, then over that study is known as a multiple correlation. So, example, we might be interested into the studying that is a joint effect of the amount of manure using that is a extended area in which the crop is raised on the yield of crop that is obtained. In such scenarios we can apply that multiple correlation. Now, next year multiple correlation coefficient identification. Suppose we have a trivial data, the multiple correlation coefficient of x1 on x2 and x3 already we identify the regression equation coefficient I want to multiple correlation coefficient I want to identify. Here also x1 on x2 and x3, so that it is denoted by the R1.23. So, that it is a correlation coefficient between x1 is estimated value given the plane of regression on x1 on x2 and x3. So, that is defined into the formula R1.23 whole square equal to R12 whole square plus R13 whole square minus 2 times of R12 into R13 into R23 whole divided by 1 minus R23 whole square. So, it is equal to 1 minus omega by omega 11. So, above formula will be expressed into the multiple correlation coefficient. It is the terms of the total correlation coefficient between the variables. This is the overall idea about it. Similarly, if I go for that is when we have taken that is variable 2 is depends on 1 and 3. So, there it is a multiple correlation coefficient is a R2.13 whole square, that equal to R12 square plus R23 square minus R12, R13, R23 divided by 1 minus R13 whole square. So, that equal to 1 minus omega divided by omega 22. Similarly, I can go for that is a R 3.12, means the third variable is depends on 1 and 2. So, R 3.12 whole square equal to R 13 whole square plus R 23 square minus 2 times of R 12, R 13, R 23 divided by 1 minus R 12 whole square. So, directly 1 minus omega by omega 33. Like here, we can be used that is a multiple correlation coefficient formulas. So, this is a simple concept. It is a multiple correlation coefficients, means it is a x1 on x2 and x3. Correlation coefficient is how much? Similarly, 2 on 1 and 3 and 3 on 1 and 2. So, such scenarios we can identify that formulas are the multiple correlation coefficients. Now, we go for that. It is the properties of multiple correlation coefficients. In this concept, multiple correlation coefficient measure that it is a closeness of association between the observed values of variable and the estimated value of the variable based on the linear regression of that particular variable on that other variable. So, that is a first property. What is the first property? It is a multiple correlation coefficient measures the closeness of associated between the observed value of the variable and the estimated value of the variable based on the linear regression of the partial variable on other variables. Second is when we will be identify R1, 2, 3, it must be in between 0 and 1, R2.12 between the 0 and 1. Like here, this is a property is must be, because of correlation coefficient must be in between 0 and 1. It is a, we will apply that multiple correlation coefficient, even that it is a 0 less than or equal to, or correlation coefficient is less than or equal to 1. So, it lies between the 0 and 1 only. R1, 2, 3 equal to 0 means it is a x1 variable depends on second variable and third variable. Such a scenario, it is a correlation coefficient equal to 0. What we can conclude, that is called as a all total and partial correlation involves that x1 are 0, x1 are 0. If third another property R1, 2, 3 equal to 1, then it is association if perfect and all the regression residues are 0. So, it is no errors. R1, 2, 3 greater than or equal to R12, R13 and R23, then it is a R1.23 is not less than any total correlation coefficient. These are the properties of correlation coefficients. Now, I am going to find out that correlation coefficients, multiple correlation coefficients, some example. R12 he has given 0.6, R13 equal to 0.7, R23 equal to 0.65. He will ask the question, find the multiple correlation coefficient. So, R1.23, it is the first variable or depends on 2 and 3, and the second variable depends on 1 and 3, R2.13, and R3.12, it is the third variable depends on 1 and 2. So, such values you will ask. So, R1.23 equal to root over R12 whole square plus R13 whole square minus 2 R12, R13, R23 divided by 1 minus R23 whole square equal to 0.7255. Similarly, I can identify that R2.13 equal to root over R12 whole square plus R23 whole square minus 2 times of R12, R13, R23 by 1 minus R13 whole square equal to value is above values directly we substitute that 0.6810. R3.12 equal to root over R13 whole square plus R23 whole square minus 2 times of R12, R13, R23 divided by 1 minus R13 whole square. So, that it is a R23 whole square. So, that it is 0.7567. This way we can identify these are here correlation coefficients he will give. Then it is a multiple correlation coefficients, capital R's we should be identifying. Next, some more examples. Here trivial data, similarly he will give that is a sometimes it is R13 and R23 equal to 0. Find the values of R.23, R.2.13, R.3.12. Okay, we can identify the values. It is a by using the same formulas only. Here next question also by using the same formulas also we can identify the values. From this observation, whether it is properties are satisfied or not satisfied, whether it is multiple correlation coefficients lies between zeros and 1. So, it is satisfied or not. It is not satisfied, it is not, data is not having the error, that we can be identify the in this concept. Now, calculation of the correlation coefficients, it is a formulation of the partial multiple correlation is a partial correlation formula is a Rij, and the multiple correlation formula is a Rijk. So, it is a Rijk formulas directly. Here we have Rijk whole square equal to bottom of Rij whole square plus Rik whole square minus 2 Rij Rjk Rik divided by 1 minus Rjk whole square. This is a generalized formula of multiple correlation coefficient. This is a partial correlation coefficient. Now, here calculate the partial correlation for the problem 1. What is the problem 1? Here problem 1 is clearly R12 equal to 0.7, R13 equal to R23 equal to 0.5. So, these values I am taking, I am calculating the regression coefficient. It is multiple correlation coefficient, capital R's, and correlation coefficients are bottom up. So, this is a values I am going to identify. Now, what is that? It is a simplification. R12 equal to 0.7, R13 equal to 0.5, R23 equal to 0.5. R12.3 equal to, I am substituting the above formula directly, I will get this is a value 0.6. So, it is lies between 0 and 1. Now, very good. Now, it is R13.2. Here also R13 minus R12, R23 divided by root over 1 minus R12 whole square into 1 minus R23 whole square. That equal to 0.5 minus 0.7 into 0.5 divided by root over 1 minus 0.7 whole square, 1 minus 0.5 whole square equal to 0.5 minus, here product is 0.35 divided by root over 0.51 into 0.75. That value is equal to 0.15 divided by root over 0.3825. So, this is also lies between 0 and 1. Now, here I am going for that this simplification R23.1. Here also I obtain that 0.2425. It is also lies between 0 and 1. Now, it is a partial correlation coefficients, partial correlations are clearly satisfied. Next, multiple correlation coefficients I will find out here. Now, R1.23 whole square equal to R12 whole square plus R13 whole square minus 2 R12 into R13 R23 divided by 1 minus R23 whole square. So, it is a 0.7 whole square plus 0.5 whole square minus 2 times of 0.7 into 0.5 into 0.5 divided by 1 minus 0.5 whole square. So, this simplification is 0.7211. So, it is also satisfied. So, it is a multiple correlation coefficient is exist. Next, R2.13 whole square equal to R12 whole square plus R23 whole square minus 2 R12, R23, R13 divided by 1 minus R13 whole square. So, 0.7 whole square plus 0.5 whole square minus 2 times of 0.7, 0.5, 0.5 divided by 1 minus 0.5 whole square equal to 0.52. So, R2.13 equal to 0.7211. So, it is also property satisfied. Now, I will go for that R3.12 whole square. Here also I will use this formula, then I will get that 0.5423. So, all the values are the properties clearly satisfies. So, here partial correlation coefficients and multiple correlation coefficients also it is clearly we obtained. If I go for the problem 2, what is the problem 2? Here second question, here trivial data R12 equal to 0.9, R13 equal to 0.7, R23 equal to 0.7. Then it is he is asking the same R capital R's and small r's. Now, when it is a multiple partial and multiple correlations. Now, I will use that formulas same, calculate the partial correlation coefficients of problem 2. So, that it is a 0.9 and I will use that it is if I use the 0 and 0.7, then it is a minus, I got it. It is a minus 0.5. It is clearly it is a result is outside, that is a value of the range of minus 1 to plus 1, because of minus 0.23. It will go for that more than minus 1.56. It is a out of border. So, that minus 1 to plus 1 only it is needed. So, that but it is a outside the data. So, here data is a range is not validated. Next, it is a R13.2. Here also I will use the formula. Then substituting the values, I got it 1.0.54, but it is a properties are not satisfied. So, data having that is errors, but that in that data unnecessary data we can be removed by using that is a linear effect. Next, it is going for that R23.1. It is resulting outside the value of the range. It is here also it is going for that 1 point something. So, it is also results is outside value of the range. This effect, how it will be affected into the multiple correlation coefficient, that I want to check it here. to the problem 2. So here R 1.23 whole square equal to R 12 whole square plus R 13 whole square minus 2 times of R 12, R 13, R 23 by 1 minus R 23 whole square. So here 0 square plus 0.75 square minus so on by 1 minus 0.7 whole square. Here also simplification is a 0, 1.05. It is also not lies between 0 and 1. Minus 1 and 1. So it is a resultant, it is a values not belongs to 0 and 1. Correlation, multiple correlation coefficient must be lies between 0 and 1. And partial correlation coefficient is lies between minus 1 plus 1. But here it is a fail. So that about data having that is a some partial errors will be there. So in that we can remove that is a estimated errors. Next R 2.13 whole square equal to, so R 12 whole square plus R 23 whole square minus 2 R 12 R 23 R 23 by 1 minus R 13 whole square. So that it is a 1.12. Here also it is a out of box. So that it is also data is not lies between 0 and 1. So here also having the error. So the resulting out of this third one is also R 3.12 whole square. Here also having that 1.0259. It is a small even the approximate, but also it is outside the value of the range. So that it is small errors will be there. Now from this it is a calculation of the values fall outside the valid range of the correlations. So suggested that initial correlation coefficients may not be the compatible in the real world trivariate distributions. So that it is not possible to apply the trivariate distributions. This is the overall idea. Now summary it comes to that correlations and the regressions that are obtained after the elimination of the linear effect of the third variable on each of the two variables are known as a partial correlation and a regression. That is the first definition. Second is a partial correlation coefficient R 12.3 is a correlation coefficient between the variable x1 and x2 after the linear effect of x2 on x1 and x3 on x1 and x2. It is eliminated. So it is also one of the summary we discussed about it. R partial correlation coefficients we identified formulas R 12.3 equal to R 12 minus R 13 R 23 divided by root over 1 minus R 13 whole square into 1 minus R 23 whole square. Now R 13.2 equal to R 13 minus R 12 into R 32 divided by root over 1 minus R 12 whole square into 1 minus R 32 whole square. And R 23.1 equal to R 23 minus R 21 into R 31 divided by root over 1 minus R 21 whole square into 1 minus R 31 whole square. Now it is in this study of another observed here joint effect of the group of the variables on another variables also that was included in the group. Then we use that as a concept of multiple correlation. That is a definition of multiple correlations we have included. Next, multiple correlation coefficient measure that it is a closeness of association between the observed value of the variable and the estimated values of the variable based on the linear regression of the particular variable on the other variable. So R 1.23 equal to root over R 12 square plus R 13 square minus 2 times of R 12 into R 13 into R 23 divided by 1 minus R 23 whole square. Here we observe the properties, some of the properties that we are going to conclude. R 1.23 like that it is a coefficients. What is that? It is a multiple correlation coefficients always lies between 0 and 1. Partial correlation coefficients it is a small r's all lies between minus 1 and plus 1. That we observed. And if the R 1.23 equal to 0 then all the total partial correlations involve that x1 are 0. And R 1.23 equal to 1 then the assumptions in the perfect and all the regression residues are 0. That also we observed. R 1.23 is not less than any total correlation coefficient, that is R 1.23 is greater than or equal to R 12, R 13, R 23 that we observe. Now here in this we have that is in this total summary here we linear effect of the third variable and it is two variables are the how it will be involved in that error observations how it will be reduced and removed. That is a summary effect is concept is observed in this partial correlation coefficients as well as multiple correlation coefficient. Here R 12.3 means it is R 12 minus R 13 into R23 by root over 1 minus R3 whole square into 1 minus 23 whole square. In this problem, he will give that is a values of R12, R13, R23 like that. It is that values we will substitute, then partial correlation coefficients we can obtain. That part of the problems, exercises, examples we discussed in this class only. Now, if we go for that is a R 1.23 means it is a multiple correlation coefficients also. Here 1.23 means R12 whole square, R13 whole square minus 2 R12, R13, R23 by 1 minus R23 whole square. It here also values of he will give R12, R13, R23, then he will ask this kind of multiple correlation coefficients values. That also we have observed and identified. And particularly we should observe here partial correlation coefficients lies between -1 and +1, and multiple correlation coefficients must be lies in 0 and 1. In this multiple correlation coefficients, two examples we have given. Here first example, it is lies, it is a total data is we can apply for that, it is a tri-distribution, tri-variate distributions we can implement. Now, here also particularly when we have a that is a not lies between, that example we have done. That example if we done that, it is a not lies between means it is a very clearly data having that is a some errors reductions. It is a whether it will be remove or fixed, that is a constant, fix that variable is a constant. That way we have to try for that. And it is here we have some effect also, but that effect without effect that we will be justify and verify in this problem. That errors reductions with that we analysis of the regression and correlations we have to be check it. Next it is comes to the multiple regression coefficient 0 and 1 only. Here 0.5 will be there, 0.75 will be there, and 0.12 will be there, 0.00025. What is that? It is also lies between 0 and 1. So, it is also the data is clearly fitted that it is more than 1.0009. Is it the effect or not? Yes, it is having the some small effect, but it is also will be the consider, and it is out of box or in box. That will be the justification we have to do here. Next, it is a multiple correlation point of view. 0 will be there. So, when it will be the minus, it is entered. So, clearly it is also out of box, minus 0.0009. It is also out of box. So, that it is in box or out box, that will be the justification we can do here. Here R12 1.23 equal to 0 means it is a x1 is a involved in the x1 or 0 variable, and R 1.23 is a regression residues are the zeros. It is a perfect associated with the distribution. It is a trivial partial correlation and partial multiple correlations will be the effectively, it will be the perfectly, it will be the effectively, it will be the exist. That we can be identified. These are the total summary points will be decide our total concept.